Welcome to Module 6 on Systems of Equations. Right now, pause the video, find a writing utensil and a piece of paper. Note-taking is going to be important so that you have access to what you're learning without having to rewatch all the videos. Plus, you can use your notes on the quizzes. Agenda for Module 6. So right now, on a new page, I want you to write Module 6, Systems of Equations. This looks like a lot. This is one of our larger modules. This will be to make up for this, you'll just have one module to do tomorrow, so that will help. Essentially, we're going to work through today solving a system using a graph, substitution, and elimination, and then we're going to work through some special systems, and we're going to talk about word problems with systems. So if you want to identify the solution to a system of linear equations, what you're looking for is the point where the lines intersect. So if we have three different systems here, and a system is just two equations graphed on the same graph, so they both need to have an x and a y, and we graph the first one, it has a y-intercept of 7 and a slope of 2, and the second one has a y-intercept of 2 and a slope of down 1 and to the right 2. We look for where those intersect, and it's at one point. So this system has exactly one solution, and that solution is at the point -2, 3. It does not have infinitely many solutions. It does not have no solution. Can't cross that off, it's too low. There we go. If we graph two lines like system B, I want you to notice that those have the exact same slope. Those lines are going to be parallel. They are never good, so we don't say that they have exactly one solution. We can't answer that. We can't say that they have infinitely many solutions. What we say is that the system has no solution because they're never going to intersect. So if I were you on your notes, I would do an A section where you show that two lines intersect and write that that has one solution. And for system B, I want you to draw two lines that are parallel. You don't need to make the whole graph. And I want you to write to yourself that that has no solution. And then system C, I want you to notice that when we graph, they end up on the exact same line. If we were to put both of these in slope-intercept form, this one would also be y equals -3x minus 1. And so you can show that on your graph by putting a set of double arrows on the line to show that there's two lines on top of each other. What that means is those intersect at every point, and so those have infinite solutions. And if you were doing this on your own paper, right, the laying down 8 for infinite solutions and the circle with the line through it for no solution, you do not have to put all of this in your notes, but I would make sure you have down A, B, and C before we move on. You tried this one on your own. Again, I would not draw all this. You're essentially just answering one of these three questions. So go ahead and try that now for system A, system B, and system C. For system A, you should have noticed that essentially what you have are two lines on top of each other, which means that at every point, so you should have chosen the system has infinitely many solutions. For system B, these lines are parallel, so that means that the system has no solution, the left. For system C, these lines intersect at one point, so these have exactly one solution at -1, -3. You can't just say one solution and stop. If there is a solution, you need to tell what it is. You need to include your point there. All right, so I want you to make a new topic, graphically solving a system of equations. We want to graph our equations and find their intersection point. So you first want to make sure that these are in a form that's easy to graph. Those are already in slope-intercept form, so we're good to go there. This one has a y-intercept of -6 and a slope of 3. We can rewrite that whole number of 3 as 3 over 1. So I'm going to go down to -6, and I'm going to go up 3 and to the right 1 and put a dot. And then because I want to look for the point of intersection, I'm going to put as many points as I can. So I'm going to go up 3 and to the right 1 again, up 3 and to the right 1 again, up 3 and to the right 1 again until I run out of room. That's going to be even easier for me because it's going to be hard for me to draw a straight line with this, so that's pretty good there. For this one, it has a y-intercept of -4 and a slope of 1, which is the same thing as 1 over 1. So we go down to 4 and we go up 1 and over 1, up 1 and over 1. And I can actually stop because I've already found the point of intersection. The point of intersection is 1, -3, and that's my solution. You pause the video and try this one on your own. I want you to notice that you'll need to get this one into slope-intercept form by adding 1 to each side. Go ahead and try this now. When you do this, you should end up with negative x plus 1 and y equals negative x plus 1. You should notice that these are exactly the same. For both of these, we had a y-intercept of 1 and a slope of negative 1, which is the same thing as negative 1 over 1. So for both of these, you should have put a point at 1 for your y-intercept, and then we go down 1 and to the right 1, down 1 and to the right 1. No reason to keep going. What we've got is the exact same line for both. So these intersect at all points. So you should have said infinite solutions for that. If this is on Alex, they're probably going to ask you to use instead of the laying down 8. All right, you pause the video and try this one on your own. For this first one, you should have noticed you had a y-intercept of negative 8 and a slope of 1, which is 1 over 1. Let's see, it's going to be hard for me to go down to 8. It should be about right here. And I need to go up 1 and to the right 1, 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 over and over and over. That's one line. This one has a y-intercept of negative 6 and a slope of 1. I want you to notice that these have the same slope, which means these are going to run parallel to one another if I graph them correctly. If they have the same slope and run parallel to one another, then you would say no solution. If you're writing this on your paper, then you would use a circle with a line through it. All right, new topic. I want you to write solving a system using substitution and underline it. When we substitute for something, we replace. So you might want to write this down that we replace a variable in one equation with an expression from another equation. So I would write down the things I have underlined there. You don't have to write down everything word for word. All right, so for this one, what you're looking for is one of your variables that's already isolated, which this one is. We know that y is the same thing as x plus 45. It's like I took your dollar and I gave you 4 quarters. They mean exactly the same, they just look different. So if I go to the other equation, y in one equation should be the exact same as y in another equation if this is a system. They're all on the same axis. They're all on the same y-axis. So I can replace that y with x plus 45. So I take my second equation, I take out the y, and I replace it with the x plus 45 because they all mean the same thing. What I've created now is an equation that looks more complicated, but it's one that's solvable because it just has one variable. So I'm going to subtract x from each side to get the like terms together. I get 45 equals 13. I'm going to subtract 13 from each side. I get 32 equals 4x. I'm going to divide both sides by 4, and so x equals 8. But that is not the solution. Remember, our solution should be a point, 8 comma something. It doesn't matter which of these you use, you get the same answer. If you use the first equation, x plus 45 becomes 8 plus 45, which is 53. If you use the second equation, it's 5 times 8 plus 13. 5 times 8 is 40. 40 plus 13 is 53. In any case, your solution should be 8 comma 53. You pause the video and try this one on your own. All right, you should have noticed that you have one of your variables isolated. Y is the same thing as 3x plus 24. Y is also equal to 9x. Everything that's in the box is exactly the same. So I'm going to take my dollar and put in 4 quarters. I'm going to replace the y with 3x plus 24. And that's equal to 9x. I'm going to subtract my 3x from each side. So I get 24 equals 6x. I'm going to divide both sides by 6, and so x equals 4. Remember, though, this is a system, so it should be 4 comma something. I need a point of intersection. You can use either equation, but I'm a lazy mathematician. I want to get something that's going to give me the correct answer, and I'm going to show my work, but I'm going to do it in the easiest way possible. That second equation is the shortest. 9 times 4 is 36, so my solution should be 4 comma 36. Now, same topic. You don't need to go on to a new topic. We're still on substitution. Everything will not always have both y's isolated. I want you to find the equation that has y isolated, which is that one. y is equal to 2x plus 1. What that's telling you is you can replace y in the other equation with 2x plus 1. So the other equation is negative 3x plus 2y equals 4. I'm going to replace y with 2x plus 1. Everything else is going to stay exactly the same. The negative 3x comes down, the 2 comes down, the 4 comes down with the equal sign. I'm just going to replace y with 2x plus 1. I need to do that in parentheses so that I remember I'm multiplying 2 times everything in y, which means I need to use my distributive property. So that's negative 3x plus 4x plus 1 equals 4. These are like terms on the same side. Negative 3x plus 4x is 1x plus 1 equals 4. We're going to subtract 1 from each side, and so x equals 3. Remember, my solution should be a point, so I have 3 comma something, but I'm not quite done there. I'm going to use the easier equation, which is the second equation, y equals 2x plus 1. I now know that x is equal to 3. Times 3 is 6, and 6 plus 1 is 7, and so my solution there should be 3 comma 7. You pause the video and try this one on your own. All right, welcome back. You should have noticed that that first equation already has y isolated. Y is the same thing as 2x plus 7. So that's telling me I can remember I'm replacing in the other equation y with 2x plus 7. So I distribute. So we have 3x plus 4x plus 14 equals 7. 3x plus 4x is 7x, plus 14 is equal to 7. We're going to subtract 14 from each side. So 7x equals negative 7. Divide both sides by 7, and so x equals negative 1. But remember, this is a system. We now know that x equal to something. I'm going to go back to my original equation because it's the easiest one to work with. I know that x is negative 1. 2 times negative 1 is negative 2. And negative 2 plus 7 equals y. Sorry, negative 2 plus 7 equals 5. So your solution there should have been negative 1 comma 5. And so when it shows it like this in Alex, it's telling you to replace x with negative 1 and y with 5. All right, new topic. Solving a system using elimination. If one variable is not isolated, so you might want to write a note to yourself that this is for when you have one variable not isolated. It might be easier to use elimination instead of substitution. To start, I want you to line both of your equations up in standard form, which these already are. Remember, standard form is ax plus by equals c. You might want to write that down in your notes if you need a reminder of what standard form is. You've got a number with an x plus a number with a y equal to a constant. We're not going to worry about whether a is positive. We're just going to make sure this is in standard form otherwise. So what we've got is negative 8x plus 3y equals 9, and 10x minus 3y equals negative 15. What we're going to be doing is looking for numbers that are opposites, like 2 and negative 2, 5 and negative 5, negative 6 and 6. When I add opposites together, they cancel out. Negative 2 and 2 make 0, 5 and negative 5 make 0, 6 and negative 6 make 0, which means the variable eliminates when that happens. If I add 4x and negative 4x, I don't get x, I get 0, which means those just go away. So I want you to notice that I've got negative 3y and positive 3y. So what I'm going to do now is add down the columns. Negative 8x and 10x make 2x. 3y and negative 3y cancel out. I do not write that as y. If I write it as y, it means 1y. And 9 plus negative 15 makes negative 6. What we create when we do that is a pretty simple one-step equation. I'm down to one variable. I'm going to divide both sides by 2, and so now I know that x equals negative 3. But remember, my solution should always be an intersection point unless it's no solution or infinite solutions. So we need to substitute that. It doesn't matter which equation you use. I usually use the one with smaller numbers just to make it easier for me. So I'm going to use negative 8x plus 3y equals 9. I'm going to replace x with negative 3. Negative 8 times negative 3 is 24, plus 3y equals 9. I'm going to subtract 24 from each side, so 3y equals negative 15. I'm going to divide both sides by 3, and so y equals negative 5. So I put that in as a part of my solution there. So remember, we're starting by lining up our equations in standard form, we're looking for opposites, and then we're adding down the columns to eliminate. You pause the video and try this one on your own. I want you to notice that they're already in standard form and you already have opposites here. So go ahead and try adding down your columns. All right, so we've got everything lined up. We've got our opposites here. 4x plus 3x makes 7x. Negative 2 and 2 cancel out. And negative 8 plus 29 is 21. We're going to divide both sides by 7, and so x equals 3. But remember, my solution needs to be an intersection point, so that needs to be 3 comma something. It doesn't matter which equation you use. I'm going to use the first one, 4x plus 2y equals negative 8. I know that x is 3. 4 times 3 is 12. 12 plus 2y equals negative 8. Subtract 12 from each side. So 2y equals negative 20. Divide both sides by 2, and so y equals negative 10. So that should be 3 comma negative 10 there for your solution. All right. We don't need a new topic. We're still working on elimination. We're still talking about when one variable is not isolated, but here's a new piece you might want to add to your notes. Sometimes we might need to multiply one or both equations to create opposite common multiples. So remember, what we need is something like 2x and negative 2x to cancel out. But we don't have that here. We've got a negative 6 and a negative 6, and we've got a positive 5 and a negative 7. Well, first of all, I want them to be opposite signs. So I'm going to focus on the y's since they're already opposite signs. And I want to think about a common multiple for 5 and 7. Forget the signs for a second. We want to think about a common multiple for 5 and 7. Some of you know right away that it's 35. If you don't, then you will need to count by 5s until you find something that works. 15, 20, 25, 30, 35, 40. And then count by 7s. 7, 14, 21, 28, 35. There we go. That's what we want, because if I were to add negative 35y and positive 35y, those would cancel out. Well, I have to turn that into positive 35 and negative 35. So the top equation is already negative 7x plus 5y is equal to negative 12. I need to multiply the y's by something to make 35. That's going to be 7. I have to multiply everything because equations work like a scale. I can't just make the y's 7 times bigger and not make everything else 7 times bigger. The bottom equation, I want to make 35 here, so I'm going to multiply everything times 5. So for the top equation, I'm going to distribute my 7. Excuse me, 7 times negative 7 is negative 49x. 7 times 35 is 35y. And I don't know 7 times 12 off the top of my head, so I'm going to put that into my calculator. 7 times negative 12 is negative 84. All I've done is multiply everything by 7. For the bottom one, it's negative 30x minus 35y equals positive 5. And I want you to notice that I've accomplished my goal, which was to have opposites of the same number, of the same sign. Positive 35y and negative 35y, when I add, are going to cancel out. For these, I'm going to add these together, negative 79. I'm going to divide both sides by negative 79. And so x equals 1. Step is the same as we've done every time. We take either one of these equations. Well, so let's use this one, negative 6y equals 1. And I'm going to replace x with 1. I'm going to solve. Negative 6 times 1 is negative 6 minus 7y equals 1. We're going to add 6 to each side, so negative 7y equals 7. We're going to divide both sides by negative 7, and so y equals negative 1. So my solution becomes 1 comma negative 1. All right, you pause this one on your own. I want you to notice that you don't have opposite signs, so one of these is going to need to be multiplied by the negative. So I would probably focus on the y's. So what I've got are 3 and 4. So I want a common multiple for 3 and 4. I'm not going to worry about the signs right now. So that's 3, 6, 9, 12, 15, 18, and so on. 4, 8, 12, ding, ding, ding. There we go. Our common multiple is 12. So we're trying to multiply these two equations times something that will turn the y's into a 12. Well, I can multiply 3 times 4 to make 12, and I can multiply 4 times 3 to make 12. But I also need these to be opposite signs. So one of these I'm going to need to multiply by a negative. Not both. If I do both, then that doesn't fix anything because now they both just turn positive. So let's see what this should look like once I do that. If I multiply everything by 4, I get negative 16x minus 12y equals 40. If I multiply everything in the bottom equation by negative 3, and this is where I make my mistake often, is I forget about the negative. That's negative 3 times negative 7, which is positive 21. Negative 3 times negative 4, which is positive 12y. And negative 3 times 10, which is negative 30. So now we're adding down the columns. Negative 16 and 21 is 5x, and 40 and negative 30 make 10. We're going to divide both sides by 5, and so x equals 2. Don't forget that our solution should be 2 comma something. So we go back, either one of these equations will work. I'm going to use the first one. Negative 4x minus 3y equals 10. X is 2. So negative 4 times 2 is negative 8, minus 3y equals 10. We're going to add 8 to each side. Negative 3y equals 18. Divide both sides by negative 3. And y equals negative 6. So your solution there should have been 2 comma negative 6. If you got that wrong, you need to go back through your steps really carefully and make sure that you understand this process before we move on. All right, sometimes when you solve these algebraically, remember, a possible solution is no solution or infinite solutions. So I want you to start a new topic, solving a system with no solution or infinite solutions. And it's okay to abbreviate the no solution and the infinite solution in your heading. You just want to be able to go back and find this later for yourself. So what we've got is 2 systems of equations. For each system, we're going to choose the best description of its solution. So what we've got here are a system of equations. I see that y is already isolated, so I'm going to use substitution. I'm going to replace y in the second equation with the 5x plus 5 from the first equation. I'm going to subtract 5x from each side to get the like terms together, and that leaves me with 5 equals 2. All right, here's what will happen. Your x's both eliminated, and now this is a scale that will always be unbalanced. 5 does not equal 2. That's impossible, and so what that means is there is no solution. If you looked at this here, you would have known that by looking at your slope. The slopes are the same, and the y-intercepts are different, so these are parallel lines. Let's look at system B. Let's solve system B using elimination. I've already got a negative 2 and a positive 2, and these are already in standard form, so that makes this perfect for elimination. I'm going to add down the columns. Negative 1x and positive 1x cancel out. Negative 2 and positive 2 cancel out. That means the only thing left on this side is 0. And 3 plus negative 3 is also equal to 0. So now, the variables have eliminated. The 2 sides are exactly balanced. This is a scale that will always be balanced, so that one is infinite solutions. You pause the video and try these on your own. All right, you should have taken a look at this, notice that it was already in standard form, and so that means we want to use elimination. I've already got a negative 5 and a positive 5, so I'm just going to add down the columns. Negative 5 and positive 5x cancel out. Negative y and positive y cancel out, which means I'm left with nothing but 0 on the left-hand side. Negative 9 plus 9 is 0. All the variables have disappeared. 0 will always equal 0, so that one should have had infinite solutions. For system B, you've already got these in standard form. I notice that I've already got a positive 1x, remember there's an invisible 1 there, and a negative 1x. Apply anything, all I need to do is add. Remember, we're adding. Negative 1 and positive 1 cancel out, but 3 and 3 do not. 3y and 3y make 6y, and 7 plus 5 makes 12. We're going to divide both sides by 6, and so y equals 2. So you should have said that this system has a unique solution, one solution. And so y has to be 2, but we don't know what x is equal to. We have to substitute it back in. So I'm going to use the first equation, x plus 3y equals 7. I know that y is 2. So that becomes x plus 6 is equal to 7, and so x equals 1. So that should be the point 1, comma 2 there. All right, new topic, applications of systems of equations. We're almost done. We're going to get through the applications and then we're going to be done. I know this was a long one. Remember, tomorrow's will be very short. At a basketball game, a vendor sold a combined total of 207 sodas and hot dogs. The number of sodas sold was 2 times the number of hot dogs sold. Find the number of sodas and the number of... So what that's telling you is these are your variables. And in a word problem, I like to use variables that stand for what I'm looking for. That makes it easier for me to interpret my solution. So I'm going to use S for sodas, even though sometimes my S's look like 5, so I'll have to be careful about that. And I'm going to use H for hot dogs. And then I'm going to start looking for totals. So I see that we've got a combined total of 207 sodas and hot dogs. These stand for the number of sodas and the number of hot dogs. So one of my equations is just sodas plus hot dogs equals 7. This one doesn't have a total. This one we're going to have to interpret. It says the number of sodas sold was. Was means equals, so it says the number of sodas sold was 2 times the number of hot dogs sold. I'm going to use substitution for this because I see that S is already isolated. S is equal to 2H, so I can replace S in the other equation with 2H. So this becomes 2H plus H is equal to 207. 2H plus 1H is 3H equals 207. We're going to divide 207 by 3. And so we find out that there were 69. I also need the number of sodas. So make sure you put your unit since it's a word problem, 69 hot dogs. I now need sodas, so there's sodas plus 69 is equal to 207. We're going to subtract 69 from each side and do 207 minus 69, which is 138 sodas. So in order to meet both requirements, having a total of 207 sodas and hot dogs sold and having twice as many sodas as hot dogs, this is the only combination of numbers that would work for that. You pause the video and try this one on your own. All right, you should have started by identifying your variables. W for washer, D for dryer. Then we're starting to look for totals. The washer and the dryer together cost a total of $900. There are no more totals. That tells me I'm going to have to translate a sentence. It says the cost of the washer is, so is means equals, 3 times, so that's 3 times the cost of the dryer. So the washer is 3 times the cost of the dryer. Again, I'm going to use substitution because W is already isolated. W is equal to 3 times D, so I can replace W in the other equation with 3D. 3D and invisible 1D make 4D equals 900. I'm going to divide 900 by 4, and I get 225 for the dryer. The washer and the dryer together cost a total of 900, so I can replace the dryer with 225, subtract 225 from each side, and I end up getting $675. A store is having a sale on jelly beans and trail mix. For 2 pounds of jelly beans and 3 pounds of trail mix, the total cost is $11. For 6 pounds of jelly beans and 5 pounds of trail mix, the total cost is $23. Find the cost for each pound of jelly beans and each pound of trail mix. All right, so remember, we're looking for variables first. So the variables that we're looking for are the cost for the jelly beans and the cost for the trail mix. So I'm going to use J for the jelly beans and T for the trail mix. And then we're looking for totals. Total cost for 2 pounds of jelly beans and 3 pounds of trail mix is $11. So that's $11. This time I'm not just adding the jelly beans and the trail mix. There's 2 pounds of the jelly beans and 3 pounds of the trail mix. There's another total of $23. 6 pounds of jelly beans, and 5 pounds of trail mix. And then I want you to pause for a second and think, should I use substitution or elimination? These are lined up in standard form and none of the variables are isolated, so this is perfect for elimination. I'm going to focus on the jelly beans because I notice that 6 is already a multiple of 2. If I look for my common multiple, it already exists in 6. So this equation doesn't have to change at all. This equation needs to be multiplied by 3. But is that going to eliminate? Remember, I need a positive 6 and a negative 6, so I'm going to multiply that top equation by negative 3. So this becomes negative 6j plus negative 9t equals negative 33. The bottom equation equals 6j plus 5t equals 23. We're going to add these together. Negative and positive 6 cancel out. Negative 9 and 5 make negative 4t. And negative 33 and 23 make negative 10. We're going to divide both sides by negative 4. And remember, this is cost. It's perfectly okay to get a decimal. We're going to do negative 10 divided by negative 4. That's 2.5, which is the same thing as $2.50. But remember, this is a system. That's the cost for the trail mix. We also need the cost for the jelly beans. I'm going to go back to my top equation, 2j plus 3t equals 11. I now know that the trail mix costs $2.50, so I can replace t with $2.50. So that's 3 times 250, and so that becomes 2j plus 7 equals 11. I'm going to subtract 7.5 from each side, so we have 11 minus 7.5, so I get 3.5. I'm going to divide both sides by 3, so 3.5 divided by 2 becomes $1.75. So it's $1.75 for the jelly beans. You pause the video and try this one on your own. All right, so you should have looked at your variables first. What we're looking for is the cost for the chair and the cost for the table. So those are going to be my variables. And then you're looking for totals. The total cost to rent 2 chairs and 5 tables is $45. The total cost to rent 8 chairs and 3 tables is $44. You should have used elimination for this one, and you should have multiplied that top equation by negative 4. You could have gotten rid of the tables if you wanted to, but then you would have had to have multiplied both top and bottom to make 15, whereas if I get rid of the chairs, I only have to multiply the top equation by negative 4. That becomes negative 8c plus negative 20t equals 45. The bottom equation stays the same because it's already an 8. Oops, I made a mistake here. I never multiplied the 45 times negative 4, so let me do that now. That should have become negative 180. Now we're going to add because negative 8 and positive 8 cancel out. Negative 20 and 3 make negative 17t, and negative 180 plus 44 become negative 136. We're going to divide both sides by negative 17. The negative 17s cancel out. You do negative 136 divided by negative 17. And so the cost for each table is 8. But I have not yet found the cost for each chair, so I go back to my top equation. It had the smallest numbers, so I use that one. The tables are $8 to rent, so I'm going to replace the tables with 8. I'm going to simplify. 2c plus 40 equals 45. Subtract 40 from each side, so c equals 5. Divide both sides by 2, and remember this is cost, so it's fine to have a decimal. The cost is $2.50. And we're going to skip these last ones. You are done. This will be available on Haiku if you need to rewatch, and will be available on each skill for Module 6. You should now complete the Module 6 practice problems in ALEKS. If you have a question about a problem in ALEKS, click on the tab that says Explanation. You'll get an explanation and a solution before you move on to a different problem. After you complete all the topics in this module, you'll need to take the quiz. That is after you have found the spot here that says Continue My Path. You should not be doing the quizzes until you have completed the practice problems. And that's it. You guys have a good day. I know this was a long one today.